This is chapter 11.2 with a focus on arithmetic sequences, specifically writing the rule for an arithmetic sequence. An arithmetic sequence is a special type of sequence where we are adding or subtracting what is called a common difference to create the next term. So for example, in the first sequence, we can see clearly that we're adding 4 each time. So this common difference, which we're going to now call lowercase d, we're going to say that it is positive 4. When it's positive, it means you're adding it. Down here, we can see that we are subtracting 0.5. So d is equal to negative 0.5. That's our common difference, d. So these are both arithmetic sequences. Now let's take a look at a couple of sequences here and decide if they're arithmetic or not. In my first example, you'll notice that each time to get to the next term, I'm adding 3. So yes, this is arithmetic, and d is positive 3. In the next example, you'll see that I'm not adding any common difference. In fact, I'm actually multiplying here by 3. So this is a sequence, but it's not arithmetic. And the last example, we can see here that each time I'm subtracting 2, so it is an arithmetic sequence, and since I'm subtracting, my common difference d is negative 2. Now we want to focus on writing the rule. And when we write a rule, we've got a general equation here that'll help us to write a rule specifically for an arithmetic sequence. This won't work for any other kind of sequence unless it's arithmetic. In other words, we have to be adding something each time or subtracting something each time. And we need two things to be able to write a rule. We need the first term, a1, and we need d, the common difference that we're adding or subtracting each time. And so here, you may want to jot this down in your note, pause the video, but the terms in red are what we're going to replace. Everything else stays put, because remember, a rule has an n in it, and it starts out with an, which means the nth term, or whatever term we want to find, is equal to some numbers, and then there's always an n in the rule. So now let's use that term, or use that formula, to write a rule for our arithmetic sequence. So remember, we always need to know what a1 is, and in this case it's negative 4, we've got it, and now we need to decide what our common difference is. We're adding 3 each time, so d is positive 3. So now I'm going to use that general formula. An is equal to a1 plus d times n minus 1, and I'm going to replace a1 with negative 4 plus, and then d is 3, and then n minus 1 stays put. And then everything's plugged in, so now all I need to do is clean up. So I'm going to do my distributive property. So negative 4 plus 3n minus 3. And when I combine like terms, I get 3n minus 7 is my rule. And then if I want to find the 47th term, then all I have to do, as we know from before, is to plug in 47 for n and to evaluate, and we get the 47th term is 134. So when we write a rule for a sequence, the information we get is going to look different from time to time. So we just saw one where it listed out the numbers. Here's a little bit different. It says, given a sequence whose first term is 25 and whose common difference is positive 9, now all we want to do is find a26. Well, I'm going to do this in two parts. Number one, if I wanted to write the rule, it would look like this. An equals 25 plus 9 times n minus 1. I could write my rule very easily here because I'm given my first term and I'm given my common difference 9, and I'd get 9n plus 16. That's my rule. And of course I could then plug in 26 for n and find out that my 26th term is 250. Now, a quicker way to do this, if I'm not asked for the rule, I could just do a shortcut and go like this. The 26th term is equal to a1, 25, plus d, and then if it's the 26th term, I know that n is 26. And when I evaluate this, I'm able to cut right to the chase and get that the 26th term is 250. Now, here's a little bit different information. Now, there's more than one way to approach these sequences and series. And so I'm going to talk us through first the algebraic way, and then I'm going to also talk us through a little bit more of a common sense way. So remember, when we write our rule, we need the first term, A1, and we need the common difference, D. So sometimes we're given what we need and sometimes we're not. Here we know that our common difference is -3. So far it's going to look like this. I need my A1. I don't have that, but I do know that my common difference is 3. And so now all I need to do is figure out what is my A1, and then I can simplify and work this out. Now, if this is the information I have, I also know that A6 is 10. The algebraic way about going about this is to do the following. I know that the sixth term is 10. So if A6 is 10, then I'm going to plug in 10 for AN. I don't know A1. I know D. But then I also know that N is 6. So I can actually work this out. And with a little algebra, I find that my first term is 25. So all I have to do now is plug in 25 for my box, and when I simplify, it turns out very nicely, and I'm able to write my rule. However, this algebraic way may not work for everybody, so we can always fall back on common sense. If I need to find my first term and I know my common difference is 3, but then I also know that my sixth term is 10, I'm going to draw 6 blanks. Here's my first term, here's my second term, my third, my fourth, my fifth, and my sixth term, which is 10. I know that I subtracted 3 each time. So I can say, well, gee, what did I subtract 3 from? Had to be 13. And then here, what did I subtract 3 from? It had to be 16. And I can actually then continue the pattern, and I have to just make sure that I'm thinking clearly and correctly about it. And the other way I can find A1 is just to back it up all the way to A1. And then the process is the same. Plug in A1 and D and get your rule. Now let's see one last example. What happens when I don't know what D is and I also don't know what A1 is? Well, I need to figure out D. So if I kind of think about this in a common sense way, I know I go up to A10, so I'm going to draw 10 blanks. Here's A10. Here's A9, 8, 7, 6. Here's A5. I have 20 and I have 35 in my sequence. Fourth term, third, 2, 1. So I need to figure out what D is. Well, whatever D is, to get from 20 to 35, I added it a grand total of 5 times. Plus D, plus D, plus D, plus D, plus D. Well, and all in all, to get from 20 to 35, that's a difference of 15. Well, whatever I added 5 times has to be divisible into 15. So in other words, if I take the 15 that I added total, 15 divided by 5, I'll find that I had to add 3 each time. So plus 3, plus 3, plus 3, plus 3, plus 3. So my common difference here has to be 3. So there is a way to kind of think it through and figure that out. But really, what we just did, without any of the blanks, is we said, okay, subtract the terms. 35 minus 20. And then to find out how many times we added it, all we have to do is subtract the ends. 10 minus 5. It's almost kind of like a slope. And that'll give me my D, which is 3. So to find D again, you subtract the terms, 35 minus 20, and then subtract the ends, 10 minus 5. And that gives us our common difference, 3. And then to find A1, we can either just draw our blanks, and we know that the fifth term is 20, and now that we know that the common difference is 3, what did we add 3 to? We had to add 17, and so we can just back it up now all the way if we want to find that the first term is 8. And remember, we can also do it algebraically. And if we do it algebraically, all I have to do now is pick one of my terms. I'll pick A5. And if I plug in 20 for AN, N is 5 then, because I'm going to use that little subscript. And I will find, the same answer whether I back it up the common sense way or if I do it algebraically. I should get the same thing, and sure enough I get the first term is 8. And from there then it's just a matter of plugging it in and getting your rule. So AN equals the first term, which we know is 8 now, plus 3 times n minus 1, and when I clean it up I get 8 plus 3n minus 3, or 3n plus 5 is my rule.
Made with Doodlecast Pro.